Hello and welcome to another trades training video. I'm Joe Carswell, and this lesson puts our drills to work to bore holes. It's all about drill bits. Let's get right into it. To start with, let's look at a twist drill bit. So you'll have the shank of the bit. This makes up the body of the whole part. You have the flutes that are cut into the bit. These will run from the tip halfway up the shank. Also, the shank turns into a smooth shank here on the end. That fits into the chuck of your drill. It'll clamp in tightly. You might see some flat faces on this shank. Those will help that bit not spin in the chuck. The purpose of the flutes on any drill bit are to help remove the material as the cutting edges cut it out of the hole. So if I turn this bit in a forward or clockwise direction, you can see the flutes moving upward. They would be removing any sawdust or whatever material is being cut out of the hole. A close look at the point of this drill bit shows you the cutting edge or cutting lip. This does all the work for the bit. All of your material is removed by this edge. On this particular standard point, you see two cutting lips. One is marked in red. When these dull out, the bit will not do its job anymore. So you can base the performance on this bit on the condition of these cutting lips. Here you see an example of two different points on this twist drill bit. One is your standard bit. It has the two edges, the two cutting edges we talked about before. Look at this split point bit. It's adding two more cutting edges. So now you have a total of four. 4 is better than 2. This bit will cut better than your standard bit. Another type of point you might see on a twist drill bit would be a brad point. And this bit here has a tiny point on the end, really sharp point. As this meets the material, it's going to hold that bit in place. You won't get any wandering from this bit like you would on the standard point or even the split point that we showed before. Another point you might find on a twist drill bit would be a pilot point. This one has a smaller drill bit on the end of a larger drill bit. This helps when you're drilling a hole to get half of that material out before you're trying to drill the larger hole. So this makes for easier drilling. A lot of times when you're drilling holes, a great method is to start with a smaller size and then work your way up. It's easier on the tool and it's easier on the drill. So the smaller size and the larger size are built into this one drill bit. So this smaller size on the tip of this drill is cutting away material, making it easier for the larger shank to work its magic afterwards. So that's some of the parts and the points of a twist drill bit. Let's look at the materials that they can be made out of. Here you see a typical high-speed steel drill bit. This is your sort of base model, okay? This is black, so that means it's phosphate coated, no special coatings. There is nothing fancy or high-tech about this bit. The most common, the most reasonably priced bit. You would typically use this bit for soft materials like wood and plastics. It can even cut some mild steel as well if you use a little oil. Drill bits can be treated or plated to make them more durable. Here you see one that has a gold coating on it. This is titanium nitride. It's a very hard plating we can put on this bit. It's going to give us more life out of it. It will also allow us to cut some harder materials, and this bit will definitely last longer. I don't have one here, but if you have some difficult materials to cut through, you might use a cobalt drill bit. These are super durable and they're not plated. This is a material alloy that's going on here. These are great for cast iron or stainless steel, which are very difficult materials to drill through. Cobalt is sort of a specialized material for a bit, and you would only use it for difficult materials that needed to be drilled. They're typically very brittle and would break easily. Bits come in different lengths as well as different sizes or thicknesses. You can see here I have a whole kit of twist drill bits, and generally the bits, the smaller they get, the shorter they're going to be. A shorter bit will break easily, so you don't want them too long. Of course, any drill bit can be made in almost any size, but these are typical ranges, and as the bit gets larger in its shank, it's going to get longer in its length. So here's an example of how long a bit can be. This bit is probably about 20 inches long, and this would be for drilling through a large or very thick masonry wall. Our different bit styles come in different sizes. There's a range for each style. Our twist drill bits are going to run the range of about 1/16 of an inch on the smallest to up to, say, 1/2 of an inch at the largest. That's your typical range for those bits. If you need a larger hole bored, you would use a different style. First up here would be our spade bit. You might hear this called a paddle bit. This is also a very reasonably priced bit, not an expensive version here. The shank on our paddle bit is much narrower than the end of the paddle bit. This part here, the width of this determines the size of the hole that it bores. These will run a range from about 1/2 of an inch on the small side up to, I've seen them 1.5 inches, sometimes even a little larger. The larger these get, the harder it is to drill a hole. And these require you to have a very straight axis when you're drilling them. If these get bound up in the hole, it'll bend the bit and it can cause you a real problem with the drill doing really funky things. You can see a point on the bit here that's similar to our brad point on our twist bit. You see these spurs on the ends here. Those are what are cutting through our material. These are setting our outside dimensions of our hole. And you also have this area in here. As you can see, this bit is flat. Those work as cutting edges as well to bore that hole. I want to mention that a spade bit does not cut a very fine hole in material. These are rough cut bits. They would be used for drilling through framing. You would not expect a spade bit hole that was drilled to be presentable. A variation on a spade bit would be a screw point spade bit. The difference between this one and this one is this is just a brad point, a very sharp point. This one has a screw tip on it. What that will do is as you turn this bit forwards into the material, that screw will pull this bit in more aggressively than this other paddle bit. You can see that in some of these curved edges on this bit, and even the way that the spurs are pointed in a certain direction. All this leads to this much faster and more aggressive boring. In the same range of hole sizes as our spade bits, we have an auger bit. This is a heavy-duty version of a drill bit. This auger bit has a screw point on the end of it. It also has some very deep flutes. That's going to remove a lot of material from the hole as we're boring. This bit also has a hex shank on it. This is 6-sided and would fit into our chuck here. We're asking a lot out of this bit, and when we put it in our drill, it needs to connect tightly and stay there. There's a lot of material that this has to work through, and it's really important that this chuck will tighten down and stay connected. You might need to drill through some masonry materials. That would be brick, concrete, concrete block. All of those materials need a special bit. None of these bits we've talked about so far will do that job. This is the one you would use, and this is a masonry bit. A masonry bit does not really cut like your typical twist, paddle, or auger bits. It literally grinds the material away using a special tip that we call a carbide tip. This has been welded or brazed on the end here, and this is going to basically just wear away the brick, masonry, or concrete until it gets through. Still has the same flutes. There's material that needs to be removed. Same shank. This tip, or this carbide tip on the end of this masonry bit, is the critical part that makes it work in those really challenging materials. If you need to drill a large hole, you might use a hole saw. Hole saws are actually a combination of parts. You're going to have your arbor, and this arbor happens to have a pilot bit connected to it. Sometimes these are removable and replaceable. As you can imagine, if this dulls out, this bit would not, or this hole saw would not work as well. You also have a collet on the back of here that you would attach any of these sizes of cups. So I have multiple sizes of cups. They all fit on the same arbor. First, you'd pick the size of the hole saw you need. You'll use the same arbor, and this slides onto the back of this. You can see there's some flat places that fit together. It's not a round hole. That helps hold these two together. You don't want them spinning as you're boring your hole. Then this nut slides back on, screws down. Now we have a one-piece hole saw that we can use to bore our hole. Our hole saws are available in a lot of different sizes, anything from a 1/2 inch all the way up to 6 inches. And the larger sizes require a lot of power from the drill to drive them. We're limited to the depth of material we can cut with this cup. As you can see here, if I lay it next to a 2x, it will barely cut through this 2x, and then it'll bottom out in the cup. We can't cut any further. What you would then do is then remove that material from the cup and then continue boring through the hole to get deeper. All hole saws have slots or knockouts punched into them so that the material that gets stuck in the cup can be removed easily, say with a screwdriver. A Forstner bit is sort of a cabinet maker's bit. This is a specialized bit that is used for finished work, say on cabinets. A really common place you'll see it is to make a place for a cup hinge to fit into a cabinet door. It makes a special cut. This is not for boring all the way through the material. This is for cutting, say, halfway through and making a flat bottomed hole in that particular material that's very finished and round and flat on the bottom. So some of the parts of this Forstner bit would be the shank. You also have these cutting edges that are defining the outside of the hole. You also have sort of a brad point in the center that's going to hold this bit and not let it wander while you're cutting. And also these edges here, these sweep sort of cutting edges, that's what's going to create that flat bottom hole or finished hole when you drill. Forstner bits travel through a sort of a medium range of sizes. Here I have a kit, this has been mine for years. This is anything from a 1/4 inch, which is actually fairly small, up to 2 1/8. I've owned this kit for a long time, and when you buy good tools, they last a long time. Someone got a hold of my kit and they ran some of this stuff through some bad wood. A Forstner bit is only for clear wood doing finished work. If you're trying to bore holes or work through framing, this would not be the bit to use. We can use our drill bits to make driving fasteners easier. This is a countersink bit, very specialized bit that has a replaceable twist drill bit in it. This is actually a tapered bit. You can see that it goes from wide to narrow at the tip, very similar to what a screw point would look like on a fastener. This part of the bit actually does a countersink process, which is boring a hole for the head of the fastener to fit flush in the material. So not only is it drilling a place for the shank of the fastener here, it's also boring a hole for head clearance to flush that out. There you have it, an introduction into drill bits, whether it's a twist bit or a hole saw. No matter what material, whether it's wood or concrete, you have choices. So thanks for watching. I'll see you in the next lesson.